iPhone 8. This phone was run over by a vehicle. It's got sent back here to me from our front-end techs after they ruled out all parts for data recovery. Customer apparently really needs this data. We're in the shop here working late. I'm very tired, but I'm going to, this is the last job, so let's get it done. Yeah. So let's pull the board, see what we're up against. At a glance, the board looks good. Looks like they already pulled the stickers. Let's see what we get for current draw. So we're at 4.2 volts, output voltage, nothing before prompt to boot, so no shorts on any main power lines. And then we'll prompt to boot here. Okay, so it's, yeah, that's a weird one. So it's hanging low and then jumping. So something must be short. Let's try shorting the power connector, and that does nothing. Okay, so let's switch back to the microscope view here. Let's start by just measuring VCC main, which we'll find right here. We'll switch to the, let's get the multimeter out here. All right, so I'll go black probe on ground. So 4.2 volts normal. So sorry, PP, that's VDD main on the iPhone 8. Now let's check VDD boost. So on our display screen here, we know that VDD boost shows up here near the boost IC. All right, so we'll measure on one of these caps. So we do have boost. Now let's take a measurement over on the power button connector here. Let's see if we have our 1.8 volts. So over in ZXW, right here on pin 13, power button, power key, connection L. So that's where we try to short the device to turn it on. This line should always be at 1.8 volts, and when you short it to 0, it signals the PMIC to start turning on the phone. So take a measurement here, black probe on ground. Interesting, so we are actually missing voltage on pin 13. I'm going to turn off DC power. Let's go into diode mode. Let's see what we get. So we're actually getting open line on pin 13. So open line on pin 13 can only really mean one thing. Let's switch over to the display screen here and I'll show you. So pin 13, we go on the other side of R4310. It should, yeah, so it goes right to PMIC, pad H14. That can only mean that this pad is disconnected from PMIC, which actually makes sense in this case because the phone took such a significant impact when it was run over, so it's fully possible that the PMIC became loose, essentially. So this pad must be loose from the rest of the board. Or there could be a damage trace from here to here, because it runs through the inner layer. So in this case, we're just going to start by removing PMIC and then checking, measuring the health of that those pads, and then we will probably, I want to say, replace PMIC and see if we make any progress. on getting this phone to boot. So let's get a fixture and get started on it here. PMIC is installed. Now what we'll do is go and we're going to actually just test the pin 13 on the power connector FPC and see if we get a normal reading now. Let's see what we get. Diode mode, red probe on ground, and measure. So that's scary. Yeah. Yeah, that's scary. But since we replaced PMIC, there's a chance that even with that torn trace, maybe PMIC itself was damaged originally, the original PMIC chip. So replacing it, even though we don't have that trace going to the power button connector, we could still prompt to boot with the DC power supply. So we're hoping that's the case. If it's not, we're going to have to adapt and find out a way to yeah, I'm very tired right now, so hopefully this worked, because otherwise I'm going to have to continue it tomorrow once I've had some sleep. Let's go back to DC power. Output voltage. So we're getting the same behavior that we were before. It's looking like a damage done to the inner layer of the board. I'm going to pick this repair up again tomorrow, see if we can do something, and if not, we're going to have to look at doing a board swap, transferring the CPU, NAND, and EEPROM information in order to recover the customer's data. So yeah, I'm off to bed, and we're going to pick this repair up tomorrow, and we will continue the video at that point. So we're back. We're ready to do the board swap on the iPhone 8 that we were working on yesterday. It's confirmed that we do have damaged traces on the inner layer of the board. The phone was run over, so this is actually common on the iPhone 8 and 8 Plus. So we're going to go ahead and do a board swap procedure on this phone, and in order to recover the customer's data. We're going to start by putting it in this fixture and removing the CPU shield. Alright, so CPU is installed. Now we're ready to test the phone. So we have the customer's NAND, customer's CPU, and we wrote the EEPROM data from the NAND to this board. We have an Apple logo. Let's see if we can make it to the passcode screen. So we've made it to the passcode screen. Touch works. So we have achieved a path to data. So this was a successful data recovery. We'll switch over to the we'll switch over to the display screen and run a recap of what we had to do. So the phone came in completely smashed. It was actually run over by a vehicle. The first thing we noticed was on J4300 was an open line reading on pin 13. If we check on the other side of this resistor, that actually leads to under PMIC on pad H14. This told us that this pad was loose, or there was a trace damage on the inner layer connecting those 2 points. We tried reballing and installing a new PMIC. That did not solve the issue. So that led us to the conclusion that there was in fact inner layer damage, which is not uncommon when the phone is run over. So we proceeded with a board swap maneuver. We pulled the customer's CPU and NAND and read the EEPROM data and copied it to the donor board, and then installed the customer's CPU and NAND, and that gave us a path to data. So we're going to be able to do a full data recovery on this phone for the customer. If you learned something in the video and you enjoyed watching, please like and subscribe, and we'll see you in the next one. Thank you.